Everyone, my name is Adi. Today I am back with LeetCode daily questions. So after a long break, right? So today's question is very interesting, and solving this question gives you a lot of chance to think deeper and to think greedy, right? So let's read the question first. What's the question? It is furthest building you can reach, right? You are given an integer array heights representing the heights of building, some bricks and some ladders. You start your journey from building 0 and move to the next building by possibly using bricks or ladders. While moving from building I to I plus 1, if the current building height is greater than or equal to the next building height, you do not need a ladder or bricks. If the current building height is less than the next building height, you can either use one ladder or zero bricks. Okay, got it. So basically, I hope you got the question. Simply, we have, you can say, an array of, you can say, buildings, and we want to see how farthest we can go up to the building and by using bricks or ladders. Let's move to Kelly draw. Give me a second. Let me first screenshot this, and then okay, how do I stop this emoji? Right. So basically, if you see, we have this image, right? Now what we simply want is, let's say at first point I am standing at here, right? Now I want to see how much far I can go. Okay. Now if you see, we only have either bricks or ladders, right? So either we can go via bricks or we can go via ladder. Now the point here comes is, this question can be solved using many ways. Like basically, let's do the greedy approach first. Like we have this array, right? Or you can say, give me a second, like let's say we have this first row, right? This is of height 4. This is of height, you can say this is of height 4. Then we have another, that is this is of height 2. Then we have this is of height 7. Then we have another that is of height 6. Then we have other that is of height 9, right? Then we have so on, like 14. And then we have another height that is 12. Now if I am standing at here and I have 5 bricks, 5 equals to bricks and 1 equals to ladders, right? I want to go to the farthest point that I can go. Now here the thing is, let's say if the building is already smaller than the current one, then I can directly jump. For example, like currently I'm at 4, I can go to 2, right? I am at here. I do not want any bricks or ladder to be used because the current building I was in, that is 4, is greater than the next building, that is 2. So I can directly jump. Now the point is, the current building I am at 2, right? And the next building is of height 7, which is obviously greater than the current building that I am on. Now there are two options with me. I can use ladder. In ladder there is no limit. Like I can jump up to any number of height from the ladder. You can say it's of unlimited height ladder, but bricks if of limited height only, right? For example, if I see the difference between these two bricks, 7 minus 2 is 5, right? Here the difference is 5. Now I at least want 5 bricks or a 1 ladder, right, to cross this building. Let's say I use 1 brick, or you can say let's say I use ladder only. Okay, I am using this ladder here. I am using this ladder, right? So I am currently at this building right now. I use ladder, so ladder will be no more with me. Currently I am only having 5 bricks. Now I can directly jump to next building because it is smaller than the current building. I am at here. Now if you see, my next building is of height 9, and the difference between these buildings is 3. Now I at least want 3 bricks or 1 ladder. But I have already consumed all my ladders, so I have the only option left with me is bricks. So I will use 3 bricks here. Let's say 1, 2 and 3. So I use 3 bricks here and I'm currently at this position, and my bricks will be reduced to 5 minus 3, that is 2, right? Now jumping on to next building, my next building and current building difference is 5. Now I at least want 5 bricks or 1 ladder, but I have already consumed 1 ladder and I'm only left with 2 bricks, so I cannot move further. Why? Because I do not have any ladder, or I do not have sufficient bricks so that I can jump the, or I can clear the difference of height. It is 5. I only have 2 bricks left, so my position that I am going to be is this only, right? And we want to return this farthest position that we can reach. Like here it will be 0, like 0, 1, 2, 3, and that is 4, right? And if you see here, that is the answer as well, like 4. The farthest we can reach was height building was 4, right? uh, let's try to understand with another example, right? Okay, for example, we have this one. Now, yeah, so now let's try to understand again with, like, here for example, here I have chosen the ladder, right? Now let's try to understand with another example. Let's say this one, right? I will move back all these things to clear the board. Give me a second. Yeah, so I'm not removing this so that I can use these again. I'm only removing these numbers. Okay, wow, Excel draw is good. Yeah, so I have the building of height, let's say 4. Then I have a building of height, let me elongate it, so that is 12, right? Another building that is 2. Give me a second, let me make it small little. Then I am using the next building of height, you can say 2. Then I have next building of height, that is 7. Then next building of, let's say 3. I'm currently solving example second, right? 18. And example, this is 20, right? And let's say 3. I'm not making further, or let's say, okay, this is my 19th building. Now let's solve this question as well. Currently I have 10 bricks, 10 equals to bricks, and I have 2 ladders. Okay, now let's solve this question. Now if you will see, I am at this building. Now my next building is obviously greater than the current building that I am on. Now I want to cross building, so I can either, the difference between those two buildings is 8, right? Now I have two options, either use a ladder or either use the bricks. Now in the previous question we used ladder first, but let's try using bricks first. Okay, now what I will do, I will simply take the 8 bricks, 1, 2, 3, and so on. Like I have consumed my 8 bricks and I'm at this one. Now my bricks will be reduced to 2, right? Now I can directly jump to the next building. Why? Because it is smaller than this one, so I can directly jump. Alright, now to move to next building I have to jump almost 5, length height 5. Now I can either use bricks or I can either use ladder. But now if you see, I am only left with 2 bricks only, so I can only use either ladders, right? So I can only use ladders. So I will use here one ladder, then I am at here, then I will go to this because it is smaller than I am here. Here also the difference between is 15. We cannot use bricks because we are only left with 2 bricks, so we will use a ladder, and with ladder we will go to up to here. Now next building is also greater, right? If you see, the difference between these is 2 only, and we are left with 2 bricks, so we can use the bricks here as well. Now currently I am at here, right? Now we are not left with any ladder on any brick, we are all empty. But I can also jump to next building because it is smaller, but at the last building we cannot jump. Why? Because it is, the distance is almost 16th, right? And we cannot jump up to this much. Now what's the index that we are currently at? 0, 1, 2, 3, 4, 5, 6, 7. So by the point we could only jump up to 7th, right? Got it. So I hope you got you learned the concept of this behind the question. But now let's try to think on, like, how we can approach this question. Now if you see, we have either two options, we have bricks and ladders. So the first intuition that got into my mind is, like, we can solve it via DP, right? And we can solve it via DP, where our possible solutions either will be either use bricks, like if in the case of take or not take, or we can use ladder, right? But if you see, or if you little bit before directly jumping to the DP question, if you see, definitely we can solve the DP question. But if you see the constraints here, all the heights of bricks and the ladders, right, are up to the to the power of 10 to the power 5 and 10 to the power 6. So, and we obviously know when we use via DP, we usually get the solution up to in the memorized solution, that like let's say the space complexity goes up to like minimum should be O of n square, right? We can solve with ON also like some DP solutions, but here if you see there are two options, so at least we will get the solution of ON square, and that will give us the memory exceeded error, right? Now if you think little greedy here, because at the end greedy solution will only work here, right? So if you think greedy here, what we can do is, as we know, we have two options, that we have bricks and ladders. Now we know that are the bricks are limited, right? But the ladder is unlimited. Now what the basic intuition says is, for the longest distances or for the longest difference, I will use the ladder, and for the shortest distances, small distances, I will use the bricks. For example, here in the previous question, if you see, like this one, I was having the longest distance, that is 15, right? Or previously I was having the distance of 8. What if for the longest distances I consume my ladders, and for the smallest distances or for the shorter distances I use my bricks, right? But now the question also occurs is, like, how do we know, like if we are already way ahead the differences, how do we know what, or you can say what previously we have solved, right? Or what previously buildings that we have jumped, so that we can use the bricks, or you can say swap the ladders and bricks now. So for that we will be using priority queue as well. Like I know, as you all know, what is priority queue. So what we will do is, let's say let's say we have this question again. Like what we will do is, we will first prioritize solving, you can say jumping with the bricks only. Like let's say we have this give me a second. Now let's say we have this question that is this line, okay, and that is another line this, and that is another line this, and there is another line this. Now what we will do is, let's say I have bricks of amount, let's say 5, and I have ladders of that is 2. What we will do is, we will first consume all our bricks, okay? Let's move to the question first. I will explain this question step by step, right? Let's say I am typing heighc dot, here I am initialized my n with the heights of the size. Okay, then we have for int I equals to, let's say I have defined my I above here, int I. Currently I am at 0th position, that's why I am initializing my size here, and I less than n, I plus plus. Now if my heights, if my height that I, if my building height that I want to jump is greater than the heights of the building that I am currently in, right, then only we want to consume the bricks. Now let's say if bricks, you can say int diff, you can say int diff, what will difference? The difference will be height of I minus right. Now this is a difference of the difference currently, right? Now if the bricks is greater than equals to difference, then what we want to do is, we want to use the bricks as well, right? So what we will do, we will do bricks minus equals to diff, right? That's all we want to do currently right now. But now let's say if my bricks are not enough, what options we have left? We have only we are only left with ladders. So we will only use the ladders, right? Else ladder greater than 0, then we will use ladders minus minus. Now if neither I have bricks or neither I have ladders, then we have to simply return that current index, return of I minus 1. Why we are returning I minus 1? Because obviously the I will be the next one, so we want to return the current building, and I minus 1 is representing the current that I am currently in, right? Yes. So we will think of the edge case later, but now let's say, now here are the things. But now if you see, we have already, we are what will it will do is, we are promoting, or you can say we are prioritizing the use of bricks first, and then we are going to ladders. But here is the crux, and here the greedy part comes. Like, okay, we have used the bricks, we have prioritized the bricks, but what if, like, let's say, now let's move to the example where our prioritization of bricks will fail, or we have to change the approach, right? So now let's say I'm at this building, and now my next building is at of height 7. Now the difference here between is 6, right? So either I need 6 bricks that we already have, or one ladder. Now we are using bricks, right? So using 6 bricks here, we will go to the next building, but our all the bricks will be consumed, right? And we are only left with one ladder. So now to move the next building, obviously we have to use ladder, and then we are at this building. Now we cannot move further because next building is obviously greater than the current building height, and we do not have anything left, neither bricks or neither ladder. But think it of another way. Like, let's say, let me refresh it. Like, rather than using the bricks here, like if I am at this building, I use the ladder first. Okay, I use the ladder first, that is ladder. Then I have left with 6 bricks as well. Then I can easily use my bricks, because one brick here, one brick here, and I will reach the end point. Now this is where we have to think greedy of how we can see where to use the ladder will be maximally optimized, and where to use bricks will be good. Now to do this, what we will do is, let's think of the greedy solution. What we will do is, we will maintain a priority queue, right? We will maintain a priority queue. The basic agenda of maintaining a priority queue is, I will tell you why we are using priority queue. Okay, so what we want here is, let's say I have used the bricks here first. We will go with our current approach only. We are giving the priority to the bricks only, right? Let's say I have used these all the 6 bricks here, right? 1 2 3 4 5 6. We have used the bricks here, right? So now what we will do is, whenever we are storing bricks, we will maintain the difference. Like here the difference was 6, then we will maintain that number into the priority queue. Now what we will do is, we are maintaining the number 6 in the priority queue now, and we have consumed all our bricks. So if you see, I only am left with ladder 1, right? So before using the ladder here, I'll see what is at the top of my queue. The top of my queue is 6, and which is all obviously greater than this current difference, right? Which is obviously greater than this current difference. So what I will say is ki, Adi, let's do one thing. Here I have consumed my bricks, right? And the difference that I am currently seeing is obviously smaller than the difference for which I have used bricks. So what I'll do is, I know that I have used bricks for this 6 difference. What I'll do is, I will pop out this 6 number and replace it with this. Like, basically simple agenda. What we are doing is, we have the difference 6, and we are swapping it with the ladder. Like here I will use the ladder now, and I will again add my number that we have used bricks. Right now I have the bricks here, because I have used the ladder here, right? I have swapped the usage of bricks here, and I am using the ladder, right? So I am again, my bricks will be equals to 6, but my ladder would be 0. Okay, Now think it of different again as well. Now when we have 6 bricks, then we can easily use this here. Now if we move to the code, what we are trying to do is, let's say URITY, okay, priority queue int, that is pq, right? Now what I am telling you, whenever we are using the whenever you are using the bricks, we will push the difference into the priority queue, right? And now when we see the if the letters is greater than equal to 0, again we have to check something, like if even I have to use the letters, I have to use the current part or the maximum part. For example, let's say if not pq dot empty and then pq dot top greater than equals to def, right? Then what you want to do is, tell me. Then we want to use the bricks, then we want to use the ladder, okay? But also we will differentiate the bricks. Like what I'm trying to say here is, give me a second. For example, bricks plus equals to, you can say pq dot top, right? And we will use the ladders here. Or what you can do is, you can simply, yeah, you can simply do this as well, okay? So basically what we are doing, we are replacing the thing. For we have to also do pq dot pop, right? And here we will return the I minus 1, only I. If I double equals to n, then return I minus 1. Why we are doing this? Because when we reach the n, we have a 0 index now, so we don't want to return the length, directly the length, we want to return the I minus 1 only, right? Now if you think I minus minus, you can simply do, right? Now here's the one thing, as I told you here, whenever we are using the bricks, we have to push the element into the priority queue as well. For example, here we are using the bricks, we have swapped the usage of bricks with the ladder, but should we also push the difference here, right? Why? Because we are using the bricks here. We cannot push equals to bricks, or you can say difference. Also here we will not be adding the pk dot top. Why? We will be adding the difference, right? So okay, I think I have to buy the LeetCode premium. Now if you see, the question is solved, but the main greedy logic is this only. The main greedy logic is this. If you understood this part, it's always easy. You can also see, I guess in the discussions forum as well, like there is one thing, yeah, this one, you can also refer this one as well. This, from this guy also I got my intuition right, that this is a good solution that we can go with, right? So we are going to upload this step. Okay, I hope you liked the video and understood the concept of this question.